Now that we have the concept of breadth first search under our belt and we understand how that can be used to find the degrees of separation between superheroes, let's apply that and actually write some Spark code to make it happen. Okay, so how do we turn breadth first search and finding degrees of separation between superheroes in our social network into a Spark problem? Let's go through that. Now this is going to make a lot more sense if that explanation of how BFS works is still fresh in your head, so if it's not, it might be a good idea to go back and rewatch the previous lecture because it will really help a lot. So the first thing we need to do is actually convert our data file, our input file, into something that looks like these nodes that we described in the BFS algorithm. So if we're starting off, for example, with a line of input that looks like this, that says hero ID 5983 appeared with heroes 1165, 38, 36, 43, 61, and 1282, what we want to do is convert that to something a little bit more interesting and useful. So we want to convert that to structured data where we have, for example, the hero ID in question, the list of their connections, a distance, and a color. So remember we had in our nodes not only their connections to other nodes, but also a distance from the hero that we want to start from, and also a color that keeps track of what's been processed and what hasn't. Okay, so this is kind of how we're going to represent one of those nodes within Spark and within Python. Now remember, our initial condition is that nodes are all infinitely distant, and we'll represent that as 9999 because, believe me, no one's going to be that far apart in a social network. And the initial color will be white, meaning everything has been unprocessed. Let's turn that into some code. So, a big part of the code is just the conversion of that source data into something that looks like a node. And what we're going to do is convert that to an actual key value pair and sort of a key of a hero ID and a value that's this composite value of the list of connections, the distance, and the color. So that way we can group things together by hero ID later more easily. So all that's going on up here is, pretty straightforward stuff. We split up the input line, extract the hero ID from the first field, and then a little bit of a Python syntax you might not have seen before. This 1 colon thing means we're going to extract all of the fields from number 1 forward. So basically that lets us iterate through all of the friends, if you will, of that hero ID that are in fields 1 going forward. And that appends them into a list of connections. Okay, so at this point we have a hero ID that we've extracted and a list of all the connections for that hero ID. Finally, we set the initial conditions like we talked about to white and an infinite distance that we're just going to represent with 9999. Except for the initial condition. So if we're starting with, say, the Hulk, and the hero ID that we're encountering is the Hulk, we know that's the guy we want to start from. So let's say we want to measure degrees of separation from the Hulk. We would color his node gray and give him an initial distance of 0, meaning that the Hulk is the Hulk and therefore is 0 degrees of separation from the Hulk. And the color gray represents that this node needs to be processed and expanded upon through the next iteration of breadth first search. And again, our final output will be the hero ID as the key, and the value will be a list of connections. Remember, this is actually a list, the distance, and the color. Okay? And then we're going to go through the entire graph multiple times. So we're going to do this as many times as it takes to find the other character that we're interested in. So we want to find the degrees of separation between 2 given characters. So we will go through each time, and we will look for gray nodes that need to be expanded upon. When we're done expanding them, we'll color them black. And as we go along coloring new nodes gray, we update the distances to increment them and keep track of the degrees of separation from our starting point, just like in the animation from the previous lecture. Now to do that, we're basically going to create a map function that will go through looking for gray nodes. And if it is gray, it's going to create new nodes, okay, that have a distance incremented by 1 and a color of gray. And these new nodes will have no connections. We'll combine them back together with their connection list in the reducer. And obviously this is going to be a flat map operation because we might be producing multiple nodes for each input node. We then color that node black, and we will copy the node itself into the results returned by the flat map operation so we don't lose it. Our reducer kind of recombines everything. So it looks for nodes tied to the same hero ID. So these are all information associated with the same node. Remember, there's only 1 node per hero in our graph, okay? So anything that comes together for that hero ID needs to be combined back together. So it's going to look for the shortest distance of all that information and preserve the darkest color for that node that we found. And then it will then find the list of connections that we passed along originally when we copied the original node back in and marry that back into the final node for this iteration. Okay. So we'll just do this over and over again until we encounter the character that we're interested in. And at that point, we can count how many iterations we've had to go through to figure out the degrees of separation. But how do we know when we're done? I mean, this is running potentially on a cluster, and there's no like set way of knowing when we've actually encountered the character we care about. Well, that's where accumulators come in. So remember how broadcast variables let you share objects across all the nodes in your cluster? Well, an accumulator allows all the executors in your cluster to increment some shared variable. So it's basically a counter that is maintained and synchronized across all of the different nodes in your cluster. So an example usage, you can call the accumulator function on your Spark context with an initial value of, say, 0, and call that accumulator object your hit counter. And then when we're going through our iterations, if any node that happens to be running this job encounters the character we're looking for, we can just increment that hit counter accumulator. And then every other node and our driver script has access to that. So after each iteration, we can check that hit counter to see if anybody incremented it, maybe even multiple people incremented it. And if it is greater than 1, we're done, right? So we know that once hit counter gets incremented by some value, we've found the guy we're looking for, and we can declare victory. Okay, so let's go look at this in action. Let's actually make it happen. Okay, we know how we're going to attack this problem from Spark, so let's actually make it real, dive in, run the code, see what happens.